Welcome to Module 3. This is where we're going to talk about energy. Um, Energy has really become an ethical issue as we look at climate change and how we're using the energy and the effect it has on the planet. Everything from income inequality to social justice. I mean, is it fair that people who can't afford to live in better neighborhoods have to suffer the consequences of our energy consumption at a higher rate than people who can afford to live places where they can say, no, don't build that power plant in my backyard. So as a topic of science and engineering, what we're going to do is we're going to study a little bit about the scientific constraints on that argument. We can't just make any argument. We can't just say, "Oh, there's going to be free energy," and I'm sure you can look up something about water-powered cars and zero-point energy and quantum this and quantum that. Okay, that's not where we're going. Okay, that's not science. Nobody's proven any of that stuff. Okay, so what we're looking at is that the Earth has a certain amount of stored energy, a combination of stored solar energy through the use of plant products or biological materials that are compressed, buried deep under the Earth. They're compressed and heated by thermal energy from the Earth. Okay, the interior of the Earth is very warm, so in the absence of oxygen under high pressure and temperature, these we can form long-chain hydrocarbons. These come in the form of natural gas, petroleum, and coal. We can mine these and we can expend them. The problem is that we end up releasing a lot of material, and not just carbon dioxide, a lot of material into either the atmosphere or the ecosystem. For instance, you might want to take a look up and see what the effect of mercury is on the human nervous system, and then take a look at how much mercury is released per ton of coal burned. And you might decide that, hey, maybe coal isn't the best way to power your lights. Okay, alternate sources of energy. Geothermal. There's everybody's familiar with the geothermal cooling system where you have tubes buried in your yard. Geothermal here means tapping into the deep thermal reservoirs of the Earth, boiling water, bringing it up, running a turbine, something of that sort. At higher temperatures, they're even talking about injecting sodium metal, and then bringing that up and using that as a means to bring that heat up, use it as a heat source. Solar, that would be photovoltaic, as well as concentrated solar. Not everything we do requires the use of electricity. A lot of industrial processes require melting things, like, for instance, glass recycling. You take cullet, this ground material, and maybe some new material, silicon, potash, that sort of stuff. Put it all together. You got to melt it down. Okay, so there's no reason to take the solar energy, convert it to electricity, and then you turn it back into heat. Okay, just keep it as heat. All right. Wind power. That one's an interesting one because the places where the wind resources exist are usually not the places where the industrial capacity of the United States exists, and so we have to figure out how to transport that electricity. So that's an issue there. Hydro. Hydro has a reputation for being very clean. If you dig into it a little further, you'll find it's not always so clean. Some of these hydro plants have been placed in situations where the varying reservoir levels cause seasonal changes in the amount of vegetation that can then be drowned. That stuff rots, releases CO2. These can be enormous releases of carbon dioxide into the atmosphere. I think worldwide that's being looked at as to some of these places that actually just need to be retired, as well as interfering with like fish migrations and just general river ecology. Some of these river ecologies depend on these seasonal floodings to maintain their courses. Okay, One that is interesting to me. I'm a gardener. And I compost. Nothing organic leaves my yard. I don't put out waste to be carted off to a landfill someplace. Everything gets composted. I've got teenagers, and so I get a lot of Amazon boxes. All the cardboard stays on the property. Okay, it all goes into the garden. Okay, that's biomass at its most basic, but that's all going to rot, and it's going to turn back into carbon dioxide, and it's going straight back into the atmosphere. And, in less than, I live in Florida, so it's going to happen rapidly, probably within 2 or 3 years. Biomass, however, what if you can take a step in and you can capture the energy that's lost that would normally happen during the rotting process, use that for human industry, and then release it? Or even capture some of that carbon and bury it deep in the earth, okay, in the form of, like, say, crystalline carbon. So basically charcoal. Okay, that's also an interesting one. Okay, it's the one that I find particularly interesting. Look up anaerobic digestion. Another thing to take a look at would be conservation. Okay, conservation has a bad reputation. At least I'm an Alaskan. Okay, I lost property during the Land Preservations Act, and my family did not prosper from those actions. Okay, so I grew up with a fairly poor opinion of conservation. Okay, but the thing to think about is if the cheap energy has made everything bigger, faster, more. We travel faster distances. We have bigger homes. We have bigger cars. We have more. And is that always better? And that's really not a scientific question. That's a question for philosophy. But where we can come in from an angle of science and engineering is to take a look at places where bigger, faster, more hasn't always been the best answer. For instance, look at your cell phone. What has happened to the size of a cell phone? What has happened to the size of computers? Okay, the computer chips keep dropping in size. Power consumption, because the mobile phones had to have these enormous batteries. They brought them down in power consumption, and were able to have many of the same capabilities, but by using less power. Okay, so does the future of our society, does it include a lower power density? Are we going to be able to accomplish many of the same things with the lower power density? Or are we going to have the same energy density? Okay, for instance, the batteries on power has to do with how fast the energy is delivered. Energy density has to do with how much energy is in a particular volume. Okay, do we need those? Do we need this? Can we have a perfectly good life without them? And on the philosophical side, though, what would it mean to meet fewer people? Okay, if you're part of a minority, then either by orientation or racially or something, or culturally, or by interests, the internet has been a huge boon to you. Okay, but what if you had a smaller community, people that your food came from closer by, your water was produced locally, your wastes were processed locally instead of being carted halfway around the world? And those are questions of ethics and aesthetics and philosophy. But there are some physical constraints that go into the argument. So have fun with it, okay?